probability. And probability is all built around this thing here, which is called the probability scale. You don't need to remember this. It's just how it's demonstrated basically. You've got 0 at this end, which is absolutely impossible, and you've got 1 at this end, which is absolutely cast iron certain. And obviously in the middle you've got a 50-50 chance and an equal chance. So if you're tossing a coin, heads or tails, you've got a 50-50 chance. The further away from 1 it is, the less likely it's going to happen, and the closer to 1 it is, the more likely it's going to happen. It never goes above 1. Okay, never goes above 1. Probability is always discussed in decimals, percentages or fractions, and it never goes above 1. Okay? And that's how it works. That's the probability scale. So the chance that tomorrow will be Wednesday is
Certain.
certain. It's going to be Wednesday tomorrow, without a shadow of a doubt. What is the probability that it will rain tomorrow? There's a good chance of that, isn't there? Because of the weather that we're in at the moment. So it's not certain, nothing's certain like that. It's not impossible. We're in a bit of a snowy situation. It's about here, I would say. Yeah, it's around about there. It's around about there. And that's basically how probability works. And as you can see, it's given as a fraction, as a decimal, or as a percentage. Okay? Obviously the fraction, the closer it is to 1, the more likely the probability. So thinking about the cards there, 13 out of 52. That's a long way away from 52 out of 52. Or mine, which was 39 out of 52, was a bit closer to 1, so I had the best probability. Same with the decimals. 0.1 is a low probability, 0.8 is quite a high probability. And again, 100%, the closer to 100%, the more likely the probability. In the exam, you will be told which format to give your answer. They'll ask you, can we have it as a percentage or a fraction or whatever. If not, you use the one that is easiest to calculate or compare. And we're going to look at a question towards the end where you do have to do that. You actually get the answer as a fraction, but it's easier once you've converted it to a percentage. So a fraction, the closer it is to 1, the more likely probability. So the probability in a single suit of cards with 13 cards, the probability of picking a number card, there are 9 number cards, these are face cards, there are 9 number cards, so you've got a 9 in 13 chance. It's a high probability that you're going to pick a number card as opposed to a face card. That would only be 4 to 13. That's it as a fraction, 9 over 13. That's a high probability. This is an old advertisement from the television, you probably don't remember it. Whiskas cat food, and the strapline used to be that 8 out of 10 cat owners said their cats preferred Whiskas. I'm not sure how they knew that, but that's the strapline. So 8 out of 10, 0.8. It's a high probability again. Yeah, it's quite a high probability. There it is, that's a high probability. And thinking back to our start again there, what we've just done, 75% chance I had, it's closer to 100%, so there's more chance for me to actually win that competition. Again, it's a high probability. So that's basically what probability is. It's worked out by, this looks like a fraction, because you've got the fraction line here. And we know that on the bottom of a fraction is the total number. So the probability on the bottom is the total number of possible outcomes, and on the top are the number of ways that an event can actually happen. So on a dice, a normal dice here, what's the probability of rolling a 5? Well, there's 6 options on the dice, 1 to 6, that's your bottom number. There's 1 5 on the dice, so that's your top number, the number of ways it can happen. 1 over 6, that's your fraction. You could make it as a decimal, 0.16, or you could make it as a percentage, 16.6. It's as simple as that. It's as simple as that. This bit obviously is asking you to remember back how to change decimals to percentages, etc., etc., fractions to decimals and stuff like that. So far so good? Let's have a practice at a few then. On a standard dice, what is the probability of rolling an even number? What's the probability of an even number?
3 out of 6.
3 out of 6. It would also be 50%, that wouldn't it? What is the probability of you having a birthday in December? There are 2 answers.
2 answers.
2 answers. What's the probability about having a birthday in December?
1 out of 12. 1 of them.
1 out of 12, yeah, because December's 1 month out of 12 months,
Oh,
or
yes,
31
yes.
out of 365, the days in the year. Yeah. Here's a tricky one. What is the probability of selecting a consonant from the alphabet?
Oh.
Okay, 21 over
20.
26.
22.
21 over 26, isn't
Yeah.
it?
21, yeah.
I'm just going to answer
21 out of 20 containing 14 brain eggs and 8 white eggs. What's the probability of getting a white egg?
8 out of 14.
8 out of 22.
8 out of 22.
8 out of 22. In total, there are 22 eggs in the box.
Right,
Yeah. In a bag of Skittles, there are 5 red sweets, 7 yellow sweets, 8 green sweets, and 5 blue sweets. What's the probability of getting a yellow sweet as a percentage? Yeah, that's a bit tricky.
25%? No. Yes. 25. No, I can't remember. 14.
Let's work it out. So we've got 5 red sweets, 7 yellow sweets. So we've got 5 red sweets plus the 7 yellow sweets plus the 8 green sweets plus the 5 blue sweets. So in total, how many sweets have we got in total there?
25.
25. So we've got 25 sweets, remember that goes on the bottom. What is the probability of getting a yellow sweet? 7. 7 out of 25. What's that as a percentage? What's the percentage out of?
100.
How have I got that?
Times it by
Times it by
4.
4. So it'll be 28.
28.
So the percentage is?
28%.
Let's check if we're right. Let's check if we are right.
Hey Pete, I got that right, mate. Do I get a prize?
28%, you get a mark for that, you get a point for that. So, oh, it's like the football draw, yeah. What's in the bag? In my bag, in this bag here, I've got 16 yellow cubes, 4 blue cubes, 8 red cubes, 10 green cubes and 2 orange cubes. Okay, that's what's in this bag. What's the probability as a percentage of drawing a green cube? You can use a calculator for this, if you need to. I don't think you'd need to, but if you need to. 10 green cubes.
Yeah.
Yeah. That's what I thought.
25%. There's a 10 in 40 chance. So it's 25%. 10 to 20, 30, 40. Draws a cube. Let's see. Let's get one out of the bag. See if it's a green one. Let's see if we're right. Oh, look at that!
What's your name back for the green?
How lucky was that? Yeah? How lucky was that? Okay. Next question. Providing we're not going to put that cube back, what is the probability of picking a red cube?
8 out of 39.
8 out of 39. Because we took a cube out. Yeah, the cube has now gone. Obviously, if that would have been a red cube that we took out here, then that would have drastically reduced to 7. out of 39. Yeah, it's a set. So basically that's what probability is all about. That's what probability is all about. It's making it into a fraction or a percentage or a decimal. Decimals are pretty rare to us. So as we said a little bit earlier on, probabilities add up to 1. So if you know the probability that something will happen, you can work out the probability that it won't happen by subtracting it from 1 or 100. So Lucy forgot to water her houseplant before she went on holiday. There is a 35% chance that the plant will be dead when she returns from holiday. What is the probability it will still be alive?
65%.
Yeah, because 35 and 65 make 100. It's as easy as that. People get a little bit worked up about probabilities, but they're quite straightforward. Let's try a couple of testers then. There are 250 employees in a business. The owner of the business is going to choose 20 employees at random to give a bonus. What is the probability of receiving a bonus, giving your answer as a percentage? Okay, giving your answer as a percentage. Use a calculator for that if you need to. So build that fraction first. So think to yourself, remember when we did fractions and we made a fraction, we learned to say back to ourselves something out of something. So what would that be? Would it be so you can try and make that into a percentage. Anybody got an answer for me?
Yeah.
At the moment? So did we build a fraction, 20 over 250?
Yeah. That's as far as I got.
Is that as far as you got?
My brain's
Okay,
not working.
that's fine. So there's our fraction. So a couple of things going on here now. We need to make that into a percentage because that's what it's asked us in the question. We know that a percentage is out of 100 at the bottom, but that's way bigger than 100 already. So what we're going to do? Well, we learnt a while ago to simplify a fraction by just removing the noughts. So 20 over 250 is the same as 2 over 25. What do we do to that? Times it by 4 to make 100. So what do we do to the top? We do the same thing.
I did 2 divided by 25 and then times it by 100.
Did you get
not 20, I did 20 divided by 250 and then I times it by 100 and got 8.
Yeah.
Yeah, same way of doing it, yeah. Same way of doing it. Let's see if we're at 8%. Yeah. So just thinking back to yourselves there about fractions, percentages out of 100, mate. Get that bottom number to 100 if you possibly can. A box contains red, blue and green counters. The probability of picking a red counter is 0.35. The probability of picking a green counter is 50%. So what's the probability of picking a blue counter?
0.15.
0.15 or 15%. How did you get that?
I did it from checking over 100.
Yeah, convert 50% to a decimal.
0.50. 0.50 plus 0.35 is 0.85, so it's got 0.15 left. Perfect. Yeah? Brandon has 3 types of sandwiches. He has 6 ham and cheese, 10 BLTs and 4 tuna. What's the probability he picks a BLT?
Oh, 10 over 20.
Yeah? Or or a 50% chance. What is the probability he picks either a BLT or a ham?
16
16 or an 80% chance. Yeah? These are straightforward, aren't they? Yeah? Let's make them a bit more tricky. Fraser is at a European roulette wheel. Among the 37 numbers available, there is a green 0. The rest are red and black in even amounts. What is the probability of getting a red number?
I'm thrown now.
Yeah. The wording of the questions
Oh,
make that
God.
slightly different, hasn't it?
18. So,
What is the probability of getting a red number?
yeah.
Somebody just say 18.
Yeah.
So 18 is your top number, isn't it? What's going to be your bottom number? What's the total number of options available on that wheel?
38.
Is it 36?
37. Among the 37 numbers available, yeah? So there are 18 red, 18 black and 1 green, so there's 37 numbers on that roulette wheel. So it's an 18 out of 37 chance. An American roulette wheel has got 38 numbers. The extra number is a green, 00. Has the probability of landing on a green number doubled?
Yes.
Yeah.
No. Yeah. 1 in 37 chance for that one. A 2 in 38 chance for that one. Yeah. So no, it's not actually doubled. It's not actually doubled. Which roulette wheel has the higher probability of landing on a black?
The European one.
Yeah, the European one. It's a 48.6 because you get 18 out of 37 against 18 out of 38. So you've got one less chance than the European one, so the higher, the probability has gone a little bit higher. So this part, and working out this part, is easy on probabilities. What is tricky are the way the questions are worded. Yeah, that's what's tricky. It's how they're actually worded. Okay, so just be careful when you read in the questions. And build that fraction. Think about when we did fractions, the bottom number of the fraction is the total number of ways that something can happen. In this case, 37 options. In that one, 38 options. And then what's the probability of what it's actually asking you, of landing on a green or landing on a black number or whatever. And that forms the top of your fraction. Once you've got your fraction, you've then, it's up to you then, is it's a decimal or a percentage depending on what the answer, what the question actually asks you to do. Okay, are we okay with those? I think we're okay with those, aren't we? Yeah, I think we're okay with those. So what happens then? Obviously, they're going to try and make things a little bit more tricky. What happens if an event happens more than once? Okay, so I'm going to roll this dice twice. Okay, what is the probability of me getting a 6 on the first roll? What's the probability of me getting a 6 on my first roll?
1 out of 6.
1 in 6, yeah? 1 in 6. I agree with you there.
Yeah.
I'm going to roll it again. What's the probability of me getting an even number?
3 out of 6.
3 out of 6. So what I've got there are my two probabilities for the event, rolling the dice twice. Okay? There are my two probabilities, two fractions. What you do with fractions, what you do with probabilities, when you get 2, you multiply them to give you the overall probability. Okay? Now remember when we multiply fractions, it times across the top, 1 times 3 is 3. It's not a very popular thing to come up in the exams. So this is why we don't, we probably haven't remembered how to do it. 6 times 6 is 36. So that means that the probability of getting a 6 on the first roll and an even number on the second roll is 3 out of 36. I could roll it for 36 times and the chance that that could happen is 3 times out of those 36. Probability of two events, you multiply them. You don't add them, you just multiply them. That's all you've got to remember.
Will it only ever be 2 events? It won't be like 3 or 4?
Always be 2.
Right.
Yeah, always be 2. Yeah? So I've done it as decimals there, to be perfectly honest, but you could do it as percentages, I think, or fractions. There it is as fractions, 3 in 36 chance. So our probabilities used are how they're going to be used in your particular exam. What's going to happen is you're going to get either a table up there, or you're going to get a tree. Tables and trees. So we're going to have a look at tables first. And these are two-way tables. So you read across and you read down depending on what the question says to you. And what they kind of like to do in these questions, they make the first part of it relatively easy. The first part of it normally concerns everybody. The amount of people that play games in this instance, the amount of people that visit shopping centres or whatever. And then the second part of it is more specific. They'll highlight certain bits of information. So, we've got a table here. It shows that we've got some English, some French and some German players. Some like to play on consoles, and some like to play on mobiles, and some like to play on PCs. You select a gamer at random. Hi Elizabeth.
Hello.
So you select a gamer at random. What is the probability that they are English and they play on a console? Let's do it as a fraction.
3 out of 15.
So 3 out of 16 or
15.
3 out of 50.
3 out of
15.
50. Firstly, we need to work out how many people there are in total, which is 50. There are 50 people in total. English play on a console, 3 of them. 3 people are English and play on a console. So 3 out of 50. Okay? 3 out of 50. Or 0.06. In France, what is the probability a gamer plays on a PC? 5 is right out of
12?
12, because there are only 12 French people in France. See, it's been more specific that. Not interested in English players, not interested in the German players, just interested in the French players. In France, what is the probability a gamer plays on a PC? What did we say it was? 5? 5 out of 12. Yeah? Or a 0.42 chance. Okay? Be careful of these questions. First part of the question will always concern everybody. The second part of the question will be a little bit more specific, and that's the key. Looking out what's the 2 specific words. France, PC. Yeah. We'll have another look at example. Here we go. Jane goes into a flower shop. What is the probability of her picking a plant with a short stem and a small flower? The table's not complete first. That's what we need to do. We need to fill the table in. We need to complete the table before we can answer the question. So let's complete the table first. What are these totals going to be? Let's start with this one there on the top right hand corner. What's that total going to be?
42.
42. Okay. What about the one underneath it?
43. Yeah.
Right, okay. We're looking at, let's carry on down. Let's go to the next one. Add those 2 together. 85. That shows us that in total in that shop there are 85 flowers. Yeah, there are 85 flowers in that particular shop. Okay. Let's come this way. What's the next number here?
58.
And finally,
27.
27. So we've worked out in that shop, large flower, small flower, long stem, short stem. You can see where it works out, but there are 85 flowers in the shop in total. So Jane's gone into the flower shop and she wants to pick a plant with a short stem and a small flower. What's that probability? Short stem, small flower. Short stem, small flower.
31 or 58.
Out of 58.
Oh, is it
85.
Oh,
Out of 80,
so-
because there are 85 plants in the shop. 31 out of 85, yeah? Of all the plants with a long stem, what is the probability of picking one with a large flower?
So 15 out of 85.
42.
15 out of 40. Of all the plants with a long stem.
Um,
Not interested in these, not interested in them.
It's like plants all over again.
Just interested in long stem, large flower. There are 15 of those, but there are only 42 long stemmed plants of all the plants with a long stem. It's that wording. It's that wording. Yeah? These are dead popular. So we're going to have a look at another one. Table below shows information about the number of unemployed and employed people in a village. Complete the two-way table. Okay, let's complete the table. Let's do this one first, 'cause it's the easiest one because we've got two numbers there. So we can easily find that missing number there. What's the number's going to go in there?
98.
98, there it is, yeah. I'm looking at my screen now. I've got this one filled in because I've added those two together.
130.
There we go. And the next one is the one underneath that.
322.
326, yeah. And then I've come this way to this number here.
So, which way?
This one here.
Oh,
So I've done 326 minus 254.
62.
72.
Close.
10 out. And then the top one.
40.
Right, so we've completed the two-way table. We've just got ourselves a mark for doing that. What is the probability that a person chosen at random is unemployed?
30 out of 327.
Got the bottom number correct?
72.
Yes. 72 actions, because there are 72 people that are employed, male and female, but there are 326 people in total. Yeah? Of the people who are employed, what is the probability that a male will be chosen?
156 out of 212.
26.
Yeah, 156 out of 254. Because that just focused on the employed people. Really popular questions, these are the exam. Really popular questions. Okay, I think I've got this one for you in the workbook, to be perfectly honest. Let's have a quick look if we have. And what this one will ask you to do is think back. So you multiply positive and negative numbers. So thinking back.
God, that was like the first
Yeah, it's like a
thing,
long
wasn't it?
time ago. It's like a long time ago. We'll do this top one here at the top. So basically what it's saying is that the last page, it is the very last page. He draws one card, which is a -9. So I'm going to do this one here, -9. Get a pen that works. And he's going to multiply it by the second card he's picked, which is a 2. -9 times 2. We've got to remember the rule. Two negatives make a positive, and a positive and a negative make a negative. What have we got here? We've got a positive and a negative, so 9 times 2 is 18. Positive and negative means minus. Yeah? Yeah? So that first one there is -18. Right, you complete the rest of the table, and we'll see where we're up to in a minute with the probability side. So maybe we've got to fill in there. 1, 2, 3, 4, 5, 6 to fill in. 6 to fill in. I'm going to start to put a few on in a second so we can see where we're up to with them all. So remember, when you're multiplying positive and negative numbers, you ignore the symbols to start with. You do the multiplication, then you apply that little rule. Two negatives make a positive and negative makes a negative. Have we all done the table? Nearly? Yeah? So, what's my next number coming up? It's going to be this one here.
Minus 20.
Minus 20? Oh, yeah. Far end of that table then? 44. Oh, that's an easy one, isn't it? 11 times 4, 44. Come to this one now. Minus 9 times minus 6.
54.
Yeah, it's a positive because we've got two negatives in the sum. 11 times minus 6.
Minus 66.
Yeah. Minus 9 times 8.
Minus 72.
Yep. And finally 11 times 8.
88.
Easy peasy, 88. What is the probability that the score is 14? What's the probability that the score is 14? How many 14s are there in that table?
1.
1. How many other answers are there?
16.
16. 1 out of 16. There's your 14. There's
Right.
16 answers. These are the cards, remember, you don't have them. So there are 16 answers, one of them's a 14. What is the probability that the score is higher than minus 18? What is the probability that the score is higher than minus 18?
So does that mean?
Does that mean you include the minus 18 or not? I would say no, above it.
But does that, when it says higher, does that mean so?
So
I'm
minus
getting
17,
confused.
minus 16.
Right, so we'll get warmer.
Yes.
Yeah.
Yeah, you get
Right.
warmer because
Okay.
remember
What's that?
minus 18 is down here, isn't it?
Right.
You're coming up, aren't you? Till you
Yeah.
get to 18, which is up here. So these are higher.
4,
Yeah.
5, 6.
So I think it's about. What did you say, 9?
Yeah, 9.
Well, that's above, isn't it?
Yeah.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. I'd say 9. Pretty confusing because, like you just said, the numbers, that number's
Graham
higher.
wants to look at
Yeah,
them.
because them numbers are higher.
Yeah.
But in terms of temperature or number, they're actually lower. Yeah. So not a terribly difficult question, but the wording again, it's the wording of the question. Okay? The wording of the question. So far so good? So let's have a look at trees. Probability trees. Okay? Don't worry about these. Don't get too upset about them. They are relatively straightforward. They look like that, okay? That's what they look like. These are called branches. These are the probabilities, and this is what happens, okay? So we're going to start with a really straightforward one, a really easy one, tossing a coin, okay? Really easy one. So whoever put that black pen. So you start off here. Now what we're going to do, we're going to toss the coin twice. So it's 2 events. So this is the first event, event number 1. It's tossing the coin the first time. Call it event number 1. So when you toss a coin, what are your 2 options? What's your 2 outcomes? Heads
Heads.
or tails? You've no other option, unless you're very clever and it lands on the edge. So thinking about probabilities out of 1, we'll do this as decimals. What's the probability of it landing on a head?
0.5.
So the probability of landing on a tail is. So then we decide we're going to toss the coin again, the second time, event number 2. Now let's say we tossed the coin the first time, we got a head, we're now going to toss it again. We have 2 options again, don't we? We have a head or a tail. Again, the only 2 options we've got. And again, it's a 50-50 chance, it's a 0.5 chance for each one. Let's say we've tossed the coin the first time and we've got a tails. We're going to toss it again. We have the same 2 options. And again, it's 0.5 times 0.5. So far, so good. So we've built our tree diagram. There it is. Now it's virtually, in exam questions, 2 is your limit. 2 events. Doesn't really go to 3. But 2 is the same method will apply for 3, but 2 is the limit. 9 times out of 10 is 2 the limit. So there's our little tree diagram. Okay, our little tree diagram. Oops, gone to the wrong slide.